Hey everybody, today we are going to review solving two-step equations. And if you remember from last year, two-step equations typically take literally 2 steps to solve. And to solve them, we end up applying the inverse operation. Remember, inverse is just a fancy name of saying opposite. And we talked about that it was important in which order you actually applied those operations. And basically it comes down to that it happens in the reverse order that we would normally do order of operations. So let's look at some examples. So here I have 2x plus 5 is equal to 11. You remember last year, the first thing we do is we divide the sides of our equation. Again, the way that I'm solving equations, there's lots of different ways to actually portray and show your work, but this is the way that the high school does it, and this is actually my preferred method of doing it. So we're going to do it vertically. So if you remember, last year, to help you remember, I told you a little story. I said the 2 and the x, these two, they are joined together by multiplication. So it's like they're joined at the hip. They are BFFs, best friends. This person right here, this plus 5, is like an acquaintance, somebody that you would say hi to in the hallway, maybe talk to in class, but the relationship is a little bit different than these BFFs. BFFs, you're going to share your secrets with, giggle, laugh, share lots of good times with. An acquaintance is somebody that you, of course, are polite to, you say hi to, but not somebody that you would necessarily tell them your secrets or even a bunch of your stories. So here we are. We're at a party and the BFFs are ready to tell us secrets. So this acquaintance needs to go away, needs to go to the other room so that the BFFs can have some private time. Well, the inverse operation, the way we get rid of this plus 5, or you can think of that as a positive 5, is to have a negative 5 or minus 5. Remember, keep your equation balanced by doing this operation to both sides of the equation. Remember, we divide the sides by the line so that we can visually see that we've actually done that to both sides. 5 and negative 5 are called inverse operations. And when we add inverse operations, or we can think of them as additive inverses, when we add additive inverses, they give us 0. Notice that I'm not putting the 0 down there because I know that it's 0. I cross it out. In algebra, we do not put anything down, any symbols, any numbers that are not necessary. I drop down my 2x. Here, I follow the rules of addition, which say I have 11 and a negative 5. Signs are different, and I'm adding, so I'm going to subtract, keep the sign of the winning digit. In other words, the one that has the most. I have more positives than negatives. This turns out to be a positive 6. Some of you may say, well, miss, that's 11 minus 5. Well, you get the same result. But sometimes when the signs are opposite here, or the signs are different, it helps you to think that we're actually just following the rules of addition. Okay, now, the girls are at a party, and they see a really cute boy and they start arguing over who's going to go talk to him. So best friends are breaking up. Yes, I agree. That's silly to break up over that, but that's just the story. So this is 2 times x. The inverse operation of multiplying by 2 would be dividing by 2. So I need to divide both sides of my equation by 2. 2 divided by 2 leaves me with 1. So this is 1x. But again, in algebra, there is an assumed 1 coefficient in front of the x. We do not write it. We know it's there. It may be invisible, but we know it's there. 6 divided by 2 is simply 3. So we end up with x is equal to 3. Now, don't forget that in algebra, a lot of the times we can check ourselves to make sure that our answer is correct. So we should always be making hundreds on our homeworks, on our quizzes, and our tests when we are solving equations because we can check it. You may use a calculator to do this. To do it, I'm going to take my original equation, and wherever I see an x, I'm going to plug in a 3. So on my calculator, I'm going to have 2 times 3 plus 5. And I'm checking to see when I press enter, if you're using a graphing calculator, or equal for a normal calculator, does that equal 11? If it equals 11, then that means the answer, 3, is a solution for this equation and that you can move on, that your answer is correct. Make sure you're always checking your work with your calculator. Okay, this example is very similar. We need to move the minus 4 by adding 4, or get rid of a negative 4 with a positive 4. Add. Oops. Yeah, no, that's right. Okay, follow the rules of addition. My signs are the same, so I'm adding. Now, get rid of multiplying by 4 by division of 4. And again, 4 times 5 minus 4, is that equal to 16 when you check it on your calculator? Okay, a little different problem. We have a fraction in there. Remember, fractions are your friends. Don't be afraid. Same situation. 2/3 times x. Best friends joined at the hip. This has to go. Or if we want to think about the order of operations, we would multiply before we add or subtract. And when we're solving an equation, we're undoing things. So the last thing you would have done with order of operations is add. So this is the first thing we have to do when we're undoing our equation. So we're going to subtract. Additive inverses make 0. Drop down what's left. Now this is really important to drop down what's left. What we're doing is now we're creating a one-step equation to solve. We need to be very clear and focused as to what numbers are we dealing with now. Some people try to just do it all up here in one step without rewriting. It's very important to show your work this way by rewriting the problem as you make it simpler and simpler. Now, to get rid of or do the inverse of multiplying by 2/3, obviously the inverse would be dividing. Okay, and last year we talked about, well, when we divide fractions, we've learned a quick little rule which said we actually end up multiplying by the reciprocal. Remember, reciprocal is this fraction flipped. So we talked about, is this step necessary? And we decided, no, we're not going to show that step. So your work should look like this. Additive inverse. We know that we're going to divide by 2/3, which means we're going to end up multiplying by the reciprocal. So that's what I'm just going to do. Multiply by the reciprocal. 3/2 times 2/3 is 1. 1x. Remember, we don't put the 1. Here, two ways to deal with it. You could do 4 times 3 divided by 1 times 2, or you could cross reduce, noticing that there's a factor of 2 that could come out of top and bottom. So on top now I have 2 times 3, which gives me 6. 1 times 1 is 1. I don't need the 1 as a denominator. It's 6 over 1 is the same thing as 6, so I'm just going to leave it at that. Don't forget to check it. On your calculator, 2 divided by 3 times 6 plus 4, enter, is that 8. Okay, notice in this problem, my x is on the right-hand side of the equation. Don't let that bother you. It's okay. Just remember, the ultimate goal is to get that variable by itself on one side, everything else on the other side. So we're just going to move things to the other side. So we're going to get rid of this minus 7 first, adding 7. Drop down what's left. What's left? An x divided by 3. Negative 1 and 7, signs are different, and I'm adding, so I actually subtract the digits, big minus small, and then keep the winning sign. There's more positives than negatives. Okay, best friends breaking up. Opposite of dividing by 3 will be multiplying by 3. Notice how I show multiplication. I'm putting the 3 in parentheses. I do not want to see dots or little x's. We don't do that in algebra. Okay, to show multiplication, we are going to put it in parentheses. Here, this is like having 3 on top, 3 on bottom. 3 divided by 3 is 1. This is 1x. This gives me 18. Plug it back in. Is 18 divided by 3 minus 7, enter, is that negative 1? This example is 2 steps because, as you can tell on the left-hand side, I have like terms. Notice them, like terms. Whenever I see like terms on the same side, I need to combine them. That's one of my first steps I do. This is like having 7 cats. I lost 4 of my cats. I have 3 cats. Now you notice it's a very simple one-step equation. Inverse of multiplying by 3 would be dividing by 3, gives me 7. Is 7 times 7 minus 4 times 7, enter on your calculator, did that produce 21? Okay, I want you to do these 4 problems on your own, so hit pause. When you're done, hit play to see the answers. Okay, here are the answers. Notice on number 1, we had to combine like terms first. Here, we got rid of the plus 7, then the inverse of multiplying by 3. This one, tricky, look at it. I have this minus m. So the first thing I have to do is get rid of a positive 7. Remember, cover up what's behind it. The sign that we're looking at is what's in front. So this is a positive 7. To get rid of it, it's a negative 7. And then you drop down what's left. What's left? A minus m or a negative m. So I get negative m is 3. This is the opposite of m, or think of that as that invisible 1. How am I going to get rid of multiplying by negative 1? I'm going to divide by negative 1. Over here, the x just happens to be on the other side, so you would get rid of the 2 first and then multiply by 5. Notice multiplication is shown by parentheses. Okay, if you need more review on this, look at section 3.2 in your textbook. You can also go to Khan Academy.